put the pH, adjusted solution. So eventually, this graphene layer, the geo layer, can be attached, by using this static electrostatic interaction, to wrap on this nanowire. So by using this way, we can form this. Here is the coaxial core shell structure. You can also form the other ones. Okay, the one we are using is in our group is we can use the graphene to encapsulate our glass bubbles. Okay, it's a quite big object. So another way is by change the surface, the chemicals surface modification by using this, the positive charging agents, the saline, PDDA, or pH, or CDAB, to positively to treat the surface of the targeting materials, for example, over there. So then the GO negatively charged, so they can, naturally attach to each other. So for example, here is an example. Say this one is the B is to show the graphene encapsulated the silicon nanospheres, and this one is to show the graphene encapsulated copper oxide. Okay, its shape is not so regular. So there is the further image is also to show this the surface modification. Okay, is similarly like this one. They can deposit on the big layer of the geo layer. So then they can wrap in a different forms. Okay, you can clearly see the wrapping the process in a different the forms. Okay. So another way is to encapsulate the target materials during the polymerization. This is mainly for the polymer-based the core materials. For example, the process is through the ionic interaction. So the geo sheet is in a solution with anion. So the tiny polymers, they form this the nanosphere. Okay. So eventually when they trigger the polymerization, the deposition is also naturally happen, to wrap the targeting materials. So eventually they can to show this the graphene wrapped the conductive spheres. So this is the original the ICM image to show the polymer microspheres. This is a graphene encapsulated one. So we can clearly to see that the graphene layer is clearly attached on the nanospheres. Okay. So another one is by using affinity-based the self-assembly. Okay, this one is in an oil in water system. So for example, this is the graphene solution, the geo solution. By adding this the mixture, the S and the CS2. So then they can have to form oil in water emulsion. Okay, and by adding this the chemicals, so this RGO is reduced in this process, but naturally they wrapped on this the core materials, and they also show this SN image and also TM image to show this RGO is is really during this reducing process they wrap the core materials at the here is a sulfur. Okay. Sulfur is another electron material in the shell. Okay, to store the energy. So here is another self-assembly method by the reduction of the GO. Is similar like the previous one. So here is the GO is in this the form, and by forming this the sulfur particles, I mean, they can deposit on this one. And eventually, when we add this the chemical to form a reduced GO, they can form this GO layer can how to say, they can self-assembly, to wrap to a spherical shape and to package the core material inside. Okay, so and also the image to show this the core shell structures. Okay, so then another method is by using this the solvent evaporation based self-assembly. So the process is also given here. The GO solutions together with the targeting materials. Okay, by using this the freeze drying method, so they can how to say this the GO the graphene layer, they can self-assembly on this. For example, the zinc oxide the layers. Okay. And also similarly by using this spray drying, okay. So our targeting materials is here, and also the GO is a mixture. I mean, by going through this tube furnace, so they can eventually to wrap the core materials. But the form is not so regular, not so spherical. But this is because due to the shape of the core materials. Okay. Okay, so I mean that's all the basically we summarize the processing way how to use the GO or RGO to wrap the materials. However, the ultimate target is to use those materials to achieve different functions. So here we just summarize those materials are to be used in, for example, as protective shells by using the GO or RGO, to store the energy, or for the bio applications, or act as a catalyst, or to enhance the Raman spectrum. So, for example, as a protective shell, here is the graphene on the silver nanoparticle. Okay, because silver nanoparticle, they have not easy to disperse, okay? Because nanoparticle is always a problem for dispersion. There's a strong tendency to aggregate for the nanoparticle themselves. And also, they are very easy to be oxidized in the air and also corrode in the environment. So there is any way we can to cover another layer to protect, right? So then, eventually, those process, to encapsulate this silver nanoparticle or even any other metal nanoparticles, they can achieve the function. For example, one is to restrain this aggregation, and also to retard or anti the oxidation, because the graphene or RGO is a really inert material for the oxidation, and also can resist the corrosion. Okay, so that's the natural property of this GO or RGO, so they can do this work. Okay. Another one is to for the energy storage. Now is graphene, the GO or RGO is widely used in electrode materials, or even used in a supercapacitor, right? So they can store the higher energy. Here is the example just to show this. This is based on the lithium sulfur battery, okay? But this sulfur cannot be directly exposed to those the solution. So the one way the researchers they are using is using the GO, to encapsulate the sulfur. To increase their repeatability and cycle numbers. Here is the data to show this application. So another application is to enhance the bioimaging. By using this the graphene, the GO layers. For example, the yeast shell itself cannot get a very clear image, but by attaching this GO or the RGO, the shape on this one, they can form the image very clear. Okay. So then is another use is for the in the catalysis areas. So that's a very wide application in this one. Here I just show the image how this the geo is encapsulated on the iron materials. To increase their catalysis properties to convert the geo. Okay. Then is another example to enhance the Raman spectra by encapsulate some gold particles or some other ones. This one is original one. This one is by encapsulate this gold particle with graphene. The peaks is much more clearer than the previous one. So. Okay. So another work in my group is, because in our group we are working on the micro encapsulations by using a different method. So the one way is one direction we are working on is we are using this the glass bubble is a hollow glass bubbles. To store a wide range of the chemicals. So because we buy this hollow glass piece from the company, they are completely sealed. Is a hollow glass bubble without any holes. But how we have developed our method, to etch a very small hole in the glass bubble, then we can store our chemicals inside. But the problem is how we can seal this hole is a very challenge. We make a hole, but we cannot seal the hole. Our original purpose is we infiltrate some reactive chemicals to be used in the self-healing materials. For example, we can infiltrate amine or epoxy resins or other diazocyanate, very reactive one. They can be stored.